All right, so we're gonna do the test review right now. For the test review, I'm gonna be going over homework problems and one factoring problem. For the test tomorrow, I'd make sure you know, at least look through the review that you guys have. Go over the quiz, and do the homework problems. So we're gonna start number one. For number one, we have 256 to the 3/4. I want to convert it to its to radicals and simplify. So for this one, what you want to do is always, anytime you have a real number, you want to put it into its prime factorization. It makes it a lot easier to work with. So 256, that's 2 to the 8. Right, 2 to the 8. Yeah. All to the 3/4. Distribute this. You have 2 to the 8 times 3 is 24 over 4, which is 6. So 2 to the 6, which is 64. That's number one. Any questions here? Now on number 8, WTR to the -1. For this one, that gives you W times T. R to the -1 is 1 over R. So W T over R. Number 28, the 12th root of 6 of x to the 6, y to the 84, z to the 96. So the root, what it's telling you is how many groups of 12 can you make with what you have inside the parentheses, inside the root. Or in other words, you can just divide the exponent by the root. So for the x, I can't take anything else, so it stays the same. 12th root of x to the 6. For y to the 84, 84 divided by 12 is 7. Is it just 7?
Yeah.
I feel like I should know that. Yeah, why is it 7? Oh, shoot. This is not starting off well. Why is it 7 on the outside? You're right. And then 96 divided by 12, that gives you 8. And then from here, because the y started even and ended odd, the y gets an absolute value. And at the same time, this 12th root of x to the 6, you can reduce that to get just the square root of x. And that's going to be your answer. We good so far? All right, 38. So I see a -8, so I'll make that into its prime factorization. That's going to be -1 times 2 cubed, then x to the 6/5, y to the 9/7, all to the 5/3. Distribute that 5/3 to everything inside the parentheses. You have -1 to the 5/3. 2 to the 3 times to the 5/3 gives you 5. X to the 6/5 times 3 gives you just 2. Y to the 9/7 times 5 over times 5/3, that gives you 15 over 7. Right? Yeah, 315. Yeah. All right. -1 to the 5/3, that's just going to give you -1. 2 to the 5th gives you 32. And then x squared, y to the 15 over 7 is the 7th root of y to the 15. So you have -32. X squared, I can take out 2 y's. And I'm left with the 7th root of 1 y left over. Any questions about that? All right. Number 42. With the 24th root of x to the 5th times the 8th root of x. So I'm going to put these into exponents. Convert them, or convert the exponents so that they have the same base. Because when you multiply two terms with the same base, you can add their exponents to get x to the 8 over 24, or x to the 1/3. which can be rewritten as the third or the cube root of x. Are we good here? Number 6, the fourth root of x to the fourth, y to the 6 times x to the 6. So for this one, what you can do, if I see two roots multiply with each other, what I'm going to do is I'm going to try to combine the roots together, where I have a fourth root and a square root. So this square root, square is the root of 2. So what you can do to convert the root into a fourth root, I can multiply the root by 2 to make it a 4. And then multiply every exponent underneath that root also by 2 to get 12. What you're essentially doing is that I have x to the 6 over 2. I'm multiplying top and bottom by 3 to get 18 over 6. It's the same exact thing, but it's a way to do it without converting to exponents. If you multiply the root, you multiply the exponent. It's just like multiplying the top and bottom of a fraction. So what you get is the fourth root of x to the fourth, y to the 6th, times the fourth root of x12 over y. So you get the fourth root of x to the 4 times x to the 12 is x to the 16 times y to the 6 all over y. Is everyone with me so far? So if 16 x's, and I want to make, how many groups of 4 can I make with those 16 x's, or 16 divided by 4? That's 4. For y to the 6 divided by 4, that gives you 1y with 2 left over, all over y. These y's cancel out, and you're left with x to the 4th times the square root of y. Since the fourth root of y squared simplifies to just the square root of y.
Is there a reason for fractions?
From the very beginning? Honestly, this problem probably would have made it easier, but I know there's a problem similar to this on the review. So I wanted to do it this way because that's how you solve it on the review. In the review, you want to combine the roots together. So I'm sure y'all should be doing the review for the test. So I wanted to show y'all this way because it's how you solve on the test. Or on the review, sorry. Which one? Oh, from 6 to 1? You could, but it ends up canceling out anyway, so it doesn't really matter. Any questions here? Are we okay? All right. Here's a challenge problem, 55. So I want to figure out what this equals. 2 times the square root of 2 times the square root times 2 times the square root, for go on forever. So for this one, the way we wanted you to solve it is that we can say that this whole thing equals x, right? If this whole thing equals x, because how infinities work and everything, if this whole thing equals x, this part right here is also going to equal x because it goes on forever. So this is the same. If I said this whole thing equals to x, I also have 2 times the square root of x. That's the green part I parentheses out. That also equals x. Does that make sense? Because it goes on forever. This part, it's kind of parentheses out with the green. That also equals the whole thing because it's going on forever. It never stops. So from here, I'm just going to solve this out. I have 2 times x to the 1/2 equals x. Divide the x over. You have 2 equals x to the 1/2 when you divide it over. Square both sides. X equals 4. Did I do that right? X, that's right. 2 times the square root of x. X to the 1/2. Yeah. X is 4. We good with that? Good. Great. All right. Number 62. So this one, you're going to multiply it all out. Distribute the 3. You have 3 plus 3 root 2. Distribute the negative root 2. Negative root 2 minus 4. So here we have 3. Well, 3 and negative 4 gives you negative 1. 3 root 2 minus 2 minus root 2 gives you a 2 root 2. That's actually a lot easier than I expected. There's your answer.
That can be difficult to keep everything.
I can do another one similar to this if you have one. Which part? From here to here? Oh, from here to here? So I divide both sides by x to the 1/2, right? So if you divide both sides by x to the 1/2, these cancel, you're left with 2. And this is just 2 over 2, right? So subtract them gives you x to the 1/2. Right, then square both sides. So you can, get this to be x, gives you 4. Yes, you have another one like this. I can, like, similar to multiplying out, I can work it out if you have one for me. Is dividing? What number is it? 55b. Oh, the division one for number 55. Sure, let's do that one. So 55b for this one, I'm gonna go and erase this page. That was division instead. So now it's 2 divided by the square root of 2 divided by the square root of 2 divided by the square root of 2 divided forever, right? So we can treat this the exact same way. I can just say, well, this whole thing equals x. I can say this whole thing equals x. And if that's true, then this whole part also has to equal x because it's going on for an infinite amount of time. So you can rewrite this as 2 divided by the square root of x equals x. And it's kind of the same thing now. You have 2 divided by x to the 1/2 equals x. If you multiply both sides by x to the 1/2, or make it a little more clear, you have 2 to the x to the 1/2 equals x. You can multiply both sides by x to the 1/2. Because when you do, these cancel out. And you have 2 equals x. This is 2 over 2. 2 equals x to the 3 over 2. And then you can raise both sides to 2/3. Because when you do, these cancel out. And you're left with x equals 2 to the 2/3, which is x equals the 3rd root of 4. So it's like a little more work just because it's division instead of multiplication, but the concept's the same. It's just set one part equal to x because it's going on for an infinite amount of time and go from there. Are we good with that? All right, number 62. Do y'all want me to do a harder version of this before we keep going? Or are we good? If you want me to do a harder one, just show me tell me the problem. 68. Okay. So we're gonna do 68. That's square root of 2 plus the cube root of 2, 1 plus the cube root of 4. All right. So it's the same concept. We're going to distribute the first one out. So root 2 times 1 is root 2. Root 2 times the cube root of 4. We're just going to leave that as root 2 times the cube root of 4. Distribute the cube root of 2. Get the cube root of 2. And then the cube root of 2 times the cube root of 4. Because it's the same root, you can just multiply what's underneath it. 2 times 4 is 8. So from here, the hard part is going to be dealing with this part right there. because you have two different roots. You need to make sure they have the same root because you don't want a root multiplied with another root. You want it all underneath one root. So what I'm going to do, I'm going to take this 4 and change it into 2 squared because I'm going to change them all into root or to exponents, sorry, to make it a little easier to work with. So the square root of 2, I don't need to convert that because I'm not dealing with it. It can stay by itself. But this root 2 times cube root of 4, I'm going to change that to 2 to the 1/2 times 2 to the 2/3. The cube root of 2 can stay. There's nothing I can do with it. And the cube root of 8 is just 2. Right, I'm only going to change my roots or my radicals into exponents if I can actually do something with it or if I need to for some reason. The root 2 and the cube root of 2, there's no need to change them because I'm not going to do anything with them. But the middle part, I am going to deal with that. So 2 to the 1/2, that's the same thing as 3/6. And this 2/3 is the same as 4/6. Right, I'm going to change them so they have the same denominator because they have the same base. So if they have the same denominator for the exponent, you can rewrite it as the square root of 2 plus this becomes 2 to the 3rd times 2 to the 4th to the 1/6. So honestly, the base doesn't matter. They don't need to be the same. What matters is that the denominators are the same because if they're the same, you can factor it out. And that's what happened on the quiz. You had two bases that weren't the same. That's okay because all you need to do is make sure that the denominators are the same because you can factor it out like I did like right here. So you get the square root of 2 plus the 6th root of 2 to the 7 plus the cube root of 2 plus 2. Or you can say you have 2 plus you can factor out 1, 2 and be left with the 6th root of 2 plus the cube root of 2 plus 2. And there's nothing else I can do there. Are you okay with that? Any questions? No questions? Great. All right, so let's do some 11.3 now. So 11.3 for number 95. This is what I have. I need to solve for x. So anytime you're dealing with something like this, you want to isolate the x, wherever the x is, you want to isolate it. So I'm going to add 25 over first to get 11 over 27 times x plus 24 to the 5/4 equals 99. Then multiply both sides by 27 over 11. So these cancel out. This becomes a 9. Then you have 9 times 27, whatever that is. Well, it's 63, 18, 243. Is that what it is? So x plus 24 to the 5/4 equals, did I say 243? Okay. 243. And then from here, for these types of problems, I'll be really careful with these. I would get rid of these one by one. I would get rid of the 4 first. Actually, before that, I'll change 243. That's 3 to the 4th, I think, right? Find out. Three to the 5th. Okay. So it's 3 to the 5th. So 243, I'm gonna change that to 3 to the 5th first. Anytime you have a real number, it's best to put into its prime factorization. And then I'm gonna work on getting rid of this 5/4. So the first thing I can do is I can multiply or raise both sides to a power of 4. Because when you do, these 4's cancel out. And I'm left with x plus 24 to the 5th equals 3 to the 20th power. And then from here, I'm going to take the 5th root of both sides. So you get x plus 24 equals 3 to the 4th. Everyone with me? So something I want you guys to be careful of is that this is just the fifth root, but if it was an even root instead, if I was like taking the fourth root of something, you had to put a plus or minus. But because I'm not taking an even root, I'm taking an odd root, it's okay. But if I was taking like a square root or a fourth root or whatever it is, I think on your review, there's a fourth root. You had to put a plus or minus or it's not going to work, right? So in this case, I have x equals 24, or 3 to the fourth minus 24. 3 to the fourth is 81. So x equals 57, right? Yeah. Everyone with me? So x equals 57, but we still need to double check that it actually works. So I'm going to take this 57 and I'm going to plug it back into the original problem that we had, because you need to check them. So for x equals 27, 27, right? Yeah, 57. What we get is 11 over 27 times 57 plus 24 to the 5/4 minus 25 equals 74. So 57 plus 24 is 81. So 11 over 27 times 81 to the 5/4 minus 25 equals 74. Remember, 81 is just 3 to the fourth. So what I have is 11 over 27 times this 5/4 is just saying I have the fourth root of 3 to the fourth all to the fifth power. So really the fourth root and the 4 cancel out. Is everyone with me before I keep going? All right, the fourth root and the 4 cancel out. So what I'm left with is 11 over 27 times 3 to the fifth minus 25 equals 74. So 3 to the fifth, we said that's 243. The 243 times 11 divided by 27 is 99. So this whole part right here, if you put it into a calculator, you get 99. Minus 25 is 74. That is true. So x equals 57 is my answer. There's a lot of work. You need to do both sides. You need to solve it, and you need to check. I want to say it again, especially when you're working with the review, is a problem similar to this. But when you take an even root of something, you have to put a plus or minus, or you're not going to get the right answer. Good. Work through it first. If you have any questions, I'll come help you out. Answer key, the worked out answer key should be online. If it's not, let me know and I'll put it online. Are we good here? All right. Number 10, solve for z in this problem. So we have something like this. What we're going to do is we're going to isolate each radical by itself. Thank you. So you're going to isolate one of the radicals by themselves, and then you're going to square it and do the same thing again. So I'm going to add this 2 times the square root of 5z plus 4 to the right side. I have 3 times the square root of 2z plus 7 equals 1 plus 2 times the square root of 5z plus 4. And then from here, square both sides. On the left side, it's pretty easy. There's just one term. You get 9 times 2z plus 7. On the right side, it's the factory form of a perfect square trinomial. So if you memorize this, it'll make it a lot easier to solve out. So a plus b squared is going to equal a squared plus 2ab plus b squared. So in this case, I have my a is 1. 1 squared is just 1. Then 2ab is 2 times this 1 times this 2 times the square root. So we have plus 4 square root of 5z plus 4. And then b squared is going to give me that 2 times the square root of 5z plus 4 squared, which will be 4 times 5z plus 4. Everyone with me? And now what we're going to do is I'm going to expand everything out, add like terms, and isolate this square root. So on the left side, we have 18z plus 63 equals 1 plus 4 times the square root of 5z plus 4 plus 20z plus 16. And then I'll move everything to the left side. So subtract the 20z over, I have negative 2z. Subtract the 16, 1 is 17. Subtract the 17 over, we get, what is that, 47? 46? Equals 4 times the square root of 5z plus 4. Everyone with me? So from here, what I'm going to do to make the numbers a little easier, a little smaller, I'm going to divide everything by 2. Because these will cancel out, and you're left with 23. So you just have negative z plus 23. This reduces down to just a 2. Square root of 5z plus 4. And then we can square both sides. And what you get, negative z plus 23, same thing as the perfect square trinomial. Negative z squared is just z squared. 2 times negative z times 23 is negative 46z. And then 23 squared is 529. And that equals 4 times 5z plus 4. Everyone with me? Good. So, like before, distribute this 4 in. Z squared minus 46z plus 529 equals 20z plus 16. Subtract the 20z over. I have z squared minus 66z. Subtract the 16 over. That's 513. And that equals 0. Everyone with me so far? So from here, I need factors of 513 that add up to negative 66. That's negative 9 and negative 57. So that means this is going to factor to z minus 9, z minus 57, or that z can either equal 9 or 57. We're not sure. It could equal both. We don't know. All right. So we have our z values. What we're going to do is we're going to plug them back into the original equation to see which one works. So you always have to check. So when z equals 9, when you plug it in, copy this. Can bring this down. All right. So when z equals 9, we're going to plug it in. We have 3 times the square root of 2 times 9 is 18 plus 7 minus 2 times the square root. 9 times 5 is 45 plus 4 equals 1. There's 3 times 25, 2 times 49. So that's 15 minus 14 is 1. That's true. So z equals 9 is going to be an answer. Does that make sense? I kind of did a little quick, but we're just plugging 9 into the original problem and making sure it makes sense. Good. All right, now we're going to do the same thing for 57. So when z equals 57, bring this down. We have 3 times the square root. 57 times 2 is 104. Plus 7 minus 2 times 57 times 5, 285 plus 4, that equals 1. So you have 3 times, that's 111, minus 2 times 289. I don't think 289 has a square root, right? Oh, 17. And this is 11. Right? It's 114, did I? Oh, it is 114, you're right. Thank you. 114, so we get 121, which is still 11. So 33 minus 34 equals 1. That's not true. It's negative 1 equals 1. So 57 isn't an answer. It's just going to be 9. So your answer is just 9 here. It's a lot of work. Yeah, you should know how to do this. Any questions about that? All right. You got 2 more. So in 108, find the radius of a cone if the volume is 128 pi cubic centimeters and the height is twice its diameter. So what is the volume of a cone? Say it again. It's like 1/3 pi, or let me double check. Figure out exactly. Yeah, 1/3 pi r squared h. All right, this is the volume of a cone. We need to find the radius of a cone with a volume of 128 pi. So you have 128 pi. That equals 1/3. And I'm also told the height is twice its diameter. So height equals 2 times the diameter. So remember, the diameter is just half of the radius, or twice the radius. So height is 4r. So we have pi r squared, and instead of h, I can just plug in 4r because I want to figure out what is the radius. So I want everything in terms of r. Does that make sense? So we can solve this out. The pi's cancel out right away. And I'm left with 128 equals 1/3 times 4r squared. We can do 128 divided by 4 to get 32 equals 1/3 r cubed times the 3 over 96 equals r cubed, and the cube root of that well, it's about 4.57, but I think once in radical form, and that's what we're going to do. We're going to leave it in radical form. So we're just going to reduce 96, find the prime factorization of 96. Which is 2 to the 5th times 3. So that's the prime factorization of 96. So we can rewrite this by saying R is going to be, I can take out one group of 2. And I'm left with 2 squared times 3. Or we can say 2 times the cube root of 12. Make sense? Are you okay with this? All right. Last one's a factoring one, number 2. I think I did this already with you guys, but we'll do it again. So for this one, I have x to the 7 over 12 minus x to the 1/3 minus 12 to the x to the 1/12. So for factoring, you always want to put everything in exponents first. So we wrote it this way: x to the 7/12 minus x to the 1/3 minus 12 to the x 1/12. You want everything, all your exponents to have the same denominator, so you can see what you can factor out. This becomes 4/12. And then when you're trying to figure out what to factor out, you want to figure out, well, what's the exponent that has the smallest exponent, right? Which one has the smallest exponent? In this case, is 1/12. So you can factor out an x to the 1/12, and you're left with x to the 6 over 12 minus x to the 3 over 12 minus 12. We can rewrite this as x to the 1/12 times x to the 1/2 minus x to the 1/4 minus 12. And in this case, I'm going to do like u substitution or whatever you want to call it to try to make it look a little nicer to factor it. So my u that I'm going to pick is going to be the one that's smaller that's left over. So u can be x to the 1/4. And also I'm picking that because u squared is x to the 1/4 squared, or just x to the 1/2. So what we get is x to the 1/12 times u squared minus u minus 12. And this is going to factor to u minus 3, or sorry, u minus 4, u plus 3. Then plug your u back in. The x to the 1/4 minus 4, x to the 1/4 plus 3. And it's x to the 1/4. This right here is a difference of squares. Anytime you see your second number is a perfect square or a perfect cube, that means you can keep factoring it, right? Because this is a difference of squares since 4 is a perfect square. And what you end up getting is x to the 1/8 minus 2, x to the 1/8 plus 2. This, we can't do anything about it. And the reason why it's x to the 1/8 is because this should be in the form a squared minus b squared. So in this case, a squared equals x to the 1/4. B squared is 4. So a is the square root of all this, or you're raising it to the 1/2. So 1/8, and b is the square root of 4, which is 2. Remember, you don't keep factoring if you end with a 1, even though 1 is a perfect square and a perfect cube both. If you start trying to break down 1s, you're going to keep going on forever. So don't whenever you get a 1, just stop. Don't keep going, because you're never going to stop. Any questions? No? All right. Oh, that's all I have. Yes. U squared minus 8. That's a difference of cubes. Oh, u squared minus 8? You can still make that to a difference of cubes. It'll be 2/3 though. 2/3 and 2/3. So if u squared, so u squared minus 8, well then from here you have a cubed minus b cubed. So a cubed is u squared. A is u to the 2/3. B cubed is 8. B is 2. So what you end up getting is that this is going to factor out to u to the 2/3 minus 2 times u to the 4/3 is u squared. I just cut off. Minus or plus AB, so plus 2u 2/3 plus 4. That's what you end up getting. Because it doesn't matter what it is, you can always make it into a cube by just dividing it by 3, the exponent.
I just wanted to make sure again, you said we're not going to do a factoring pattern, right?
I didn't say that. No. Any questions, comments, concerns? A lot of concerns, I'm sure a lot of complaints too. That's okay. All right, so make sure you study everything. Quiz, factoring pattern, all that kind of stuff. And if you have any questions, let me know. I'm closing the video.